Hello again, everybody, and today we'll be doing rules in differentiation: the product rule, the quotient rule, and the chain rule. Now let's start with the product rule. The product rule is that if you want to derive a product, let's say we have d dx of fg, where f and g are both functions of x. The derivative of fg is equal to f times the derivative of g plus g times the derivative of f. So let's say we want to derive, let's say we have an equation y is equal to x plus 1 times x plus 5, and we want to derive this without expanding the brackets. We can go ahead and we can say that dy dx will be equal to x plus 1 times the derivative of x plus 5 plus x plus 5 times the derivative of x plus 1. Now, of course, you know, the derivative of x plus 5 is x, the derivative of x plus 1 is also x. So we end up with dy dx being equal to x plus 1, the derivative of, so we end up with the x plus 1. Of course, the derivative of x plus 5 is 1, and then the derivative of x plus 1 is also 1, so we just end up with x plus 1 plus x plus 5. Then we end up with 2x plus 6. And that's how it's do derivative of multiples, but you don't want to extend the brackets. When you just have two things multiplying, so then you want to derive them, you do the rule for that. The next rule, we have quotient rule. This rule is how you're dividing functions and you're trying to derive the function that you're deriving. So let's go ahead, we can say that dx of f over g is going to be equal to g df dx. So g times the derivative of f with respect to x minus f times the derivative of g with respect to x all divided by g squared. Now, for this one, you have to pay very close attention to what you're multiplying by what. It has to be the lower one times the derivative of the higher minus the higher one times the derivative of the lower, all over the lower one squared. Because it's subtraction and division, if you mix up any of these numbers, then you will get a wrong answer because subtraction and division are not commutative. Now let's move on to the final rule, chain rule. For this rule, we can write dy dx is equal to dy du times du dx, and we can see this because if we multiply these, we cancel du here, and we end up back at dy dx. Now let me show you where the u comes in. Here we have to derive, here we have y equals sin x squared, y equals sin x all squared. Now, when you're deriving sine or cos or other trigonometric functions, you can't just bring down the power. So the derivative of y equals sin x squared isn't 2 sin x. This is in which answer is incorrect. The way we go about this is that we can go ahead and we can substitute another variable u for sin x, and we can say let u equal sin x, and then we have y now being equal to u squared. Now what we can say now is that du dx is going to be equal to cos x, because we're deriving u with respect to x and we have sin x here. So du dx be equal to the derivative of sin x, which is cos x, and then dy du will now be equal to 2u derivative of u squared, and then dy dx now will be equal to du dx times dy du. We'll have dy dx equals 2u cos x. But we don't want u in our final answer, so we can go ahead and re-substitute sin x for u, and our answer will be 2 sin x cos x. And there you have it. Those are the major rules of differentiation. See you next time.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.